Okay, well, we are a smaller group today. We had lots of emails from people that they have interviews and that they won't be able to attend today or tomorrow. But that's hence why we also record them so that you have options to get into them. So welcome to those of you that are able to join us today. And we are doing our third session on matter. And hopefully we will provide you with some information that you'll be able to walk away and use. Just out of curiosity, have any of you already done matter in your classrooms? No?
Me teaching it.
You're teaching it right now? Okay.
Yeah, in conjunction with the classroom chemistry stuff.
Okay. Okay. That's a good place to do it, actually. That's a really good place. Okay, well, let's get going. And I'm going to begin with our land acknowledgement. In the spirit of reconciliation, we want to acknowledge that this gathering is taking place on traditional lands across the province of Alberta, home to many diverse Indigenous, Métis, and Inuit peoples. We acknowledge that this land is a traditional meeting ground, giving voice to its original peoples and the story of creation of this country in a way that history has forgotten. And we have an extra R, I see, so we'll get rid of that.
That's mine.
So,
sorry.
No, that's okay. No, I just thought, well, okay, that didn't look quite the same. I'm going to play a really short clip for you because matter still ties very much to, remember when we do the acknowledgement, wherever I can, I'm going to try and put some links in that support the study and the reflection and relationship that Indigenous people have with Mother Earth. So this is just a really short little clip that I'm going to play, and then we'll move on from there.
The water is in this story, the origin of life. Talks about these women, grandmothers, that were asked by the Creator, which ones will come here. First one, Creator asked, he made that one the moon. Grandmother. Second one, he made into Mother Earth. The third one, he made into water. That's the life. There's lots of life in that water. It's a woman, grandmother. The fourth one, he made into an image of woman we see walking around on earth today. That one carry life into this world of the Creator. That's where we're born from. And there's more to that. But for now, just so you know, for us people, what we're trying to do is preserve what we have. Canada's built on our traditions, built on our stories, because we were the first ones here. Everything that Canada is come from us. So if you go back to that story and know where we come from, the woman is strong, but today the woman's voice is taken out of decision-making processes in this system. That's why there's chaos. There's no more balance in that with respect to how the relationships go. That's what I was told by my grandfathers in my ceremony. We always hear this term growing up. What kind of a world are we going to leave for our children? Everything's being poisoned off. I ask, what kind of a child are we going to leave for the world? If we don't teach our children the proper way to respect Mother Earth. If we don't talk to our children and our grandchildren how to respect the environment, how to respect those birds, those animals, the trees, what kind of a world is that going to be?
Okay, so it does tie a little bit to in our last session as well with living systems, but I think it's important for us to remember that we always have an Indigenous component that we need to tie into our teaching as we go along, and wherever possible, when it makes total sense to infuse it in certain areas, I've always and will continue to try and find some resources that we can put in there for sure. So again, our hope is that at the end of our session, remember in an hour, it's pretty hard to unpack an entire unit as best we can, giving you resources, giving you some information about the concepts, the assessment sides of it. And that's really a big focus that we really want to have at the beginning, is always to plant that seed about what are the big rocks in here for assessment that we have to pay attention to. And that's where Ted is going to take you through just a wealth of information that we need to address as we go along. So just having that confidence in the efficacy that you have something in your toolbox when you do end up having to teach this particular unit or this particular section that we're working on right now, the idea that we're working on. So everything that we have in grade 5 continues through. There's no deletions. You're one of the grades that has all the things in it, including space. So we'll leave that for now. And what I want to do is just briefly touch. I don't want to unpack this document, but what I do want to touch on is just, again, the understanding that the dark of the 3 colors, the darkest line at the top, is always the organizing idea, always houses the big concept that sits throughout multiple grades. And in this particular case, it sits through 7 grades. It's the same organizing idea that goes from kindergarten to grade 6. And we need to, it doesn't matter what order we teach them in, but in the end of the year, we need to know that everybody found the same big rock and assess the same big concept. That's the key piece that we always want to keep back to revisiting in these pieces. The other thing that we need to keep in mind is that what is different about this curriculum is that you have always lived in your own box when it came to science. You had a discrete subject that started and finished in your grade. Nobody else really had to worry about. They did weather, you did weather in grade 5. That was it. We didn't do weather anywhere else. So, and I used it in the other grades as well as an example that where I had a colleague and she said, I've been teaching grade 2 for 27 years. I need some information on this. I said, go talk to grade 5. She said, I have been teaching grade 2 for 27 years. I have no idea what a grade 5 teacher teaches in science. And I've never had to think about what they teach because we've never been across the grades like this. And so this in itself has some implications for when you think about math. If you're doing K to 3 math and in the new curriculum, there's that word bridging that comes in. Well, there's bridging that's going to have to come in the science here too. You can't just launch into an outcome in grade 5 and assume that the kids that showed up at your door have the background knowledge, because they don't. So wherever possible, I'm also building in some of the bridging pieces into the suggestive resources. Just as the last time around, we're not going to do this in the next session, so we're just going to try and huddle them all together this time around. Just a reminder of the wording in that document. So when you see the word include, so for example, we have an energy one in here, physical properties of matter include, mass, volume, density, compressibility. If it says include, I have to make sure that those are part of my instructional lessons. They're not suggestive, they have to be there. But if I have others that I want to bring in, I can definitely do that. You are not limited to only those, but you must include those if they come behind include. As opposed to if we drop down to the bottom where we have such as, remember such as they're examples of what you could use in teaching this particular topic or this particular concept that you're about to unpack, but it's not saying that you have to use those. It's not saying that you couldn't use just some of them and bring some other ones in. You have discretion as the teacher as to where you want to go with that. And then the last one are any words that are in brackets. Those words that are in brackets, remember, are terms that we either have to teach and we have to make sure that students are well versed and well aware of. And as I'm teaching them, depending on the age level that they're in, I may not want to use that word every time. I might want to put more lay language in as I go along. In some cases, I might want to use that word all the way through. So we have discretion in that area as well. Okay, so now I'm going to turn it over to Ted, who's going to take us on a journey of assessment.
Thank you, Chris. Before I begin, I just want to put where we're going and what I'm going to be talking about with sort of the structure of the curriculum in a bit of a different context. We've probably been posed this question many times about what is the purpose of education? What's the purpose of what we're doing here? What do we want for our students when they leave our classrooms and our schools towards a future that is so unpredictable, so full of change and changes that we can't even imagine? So what I'd like you to do just for a few seconds is to think about what is it that our students are going to be able to know and do to be successful in a world that is so highly unpredictable. And as you think about those things, I'd just like you to watch this little video clip about a snippet of, you know, what's up and coming down the road. That fluidity is amazing. And when you pause and think about the types of skins they could put on robots now, if you can Google that and find, you know, faces of robots, they're so realistic. When a robot smiles, it gets all the wrinkles. It can show emotion so many different ways. And so, you know, we got robots that can do all kinds of things. What is it that we need our kids to be able to think and do? Before I go on though, Colette, you do have a question about the bracket statement. So maybe we can have you ask that.
Yeah, sure. What you're saying is different than what was on the Alberta Ed videos. They've said that the bracketed statements are not directed at students and for teachers only. So I'm just curious, that's different than what's in all of their videos.
Okay, well, that's interesting because that's the wording that they gave us when we went through the training. As they said, they were definitely words that we still would, like in grade 2 for math, you have reflection, you have all the transformations, and you still teach them the wording, but would it be appropriate necessarily to use that terminology with a grade 2 student consistently? And the answer was, that's up to you. And our response was probably we wouldn't do it. If they were in grade 5 or 6, we might do it. So that's interesting. But I can definitely check on that for sure.
Sure, yeah, they have a chart in their videos and it has that it's directed for teachers, and they, you know, they use example phonemes. You know, for younger kids, they don't need to know that, they need to know the sounds. So anyway, just we've been saying the opposite, so just wanted to follow up. Thanks.
Nothing would surprise me if things have changed. That's fine. No, I will absolutely check on it for sure. Thanks,
Thanks, Chris. Yeah, you bet.
Thanks, Chris and Colette. So as you just pause and think about what it is that students will be able to need for the future, and things that came to mind likely are the things that show up in the competencies, which can be found at the New Learning Alberta website. If you click on that site, they'll be listed at the bottom. So there are things like we want kids to be critical thinkers and problem solvings down the road. We want them to be good communicators and citizens. We want them to be creative and innovative and have the literacy and numeracy skills to cope with the language and numeracy issues and problems that face us down the road. So in order to meet those demands and to be able to help our kids develop those competencies and skills in literacy and numeracy, we need to be intentional about what we do with our students. We can't go through the curriculum in a checklist and say, okay, I've covered this point, and this point in a very basic format. If you look at a lot of the things, even like the understandings, you can have kids memorize the understanding and ask them that down the road. Okay, what do you understand about this? And they can retell you the understanding that you had them memorize. We can't go down that road anymore. We have to be more intentional to make sure we do things to provide our kids with the abilities and assets to be successful down the road. So the question is, how do we do that? And I'm going to have you look at the curriculum through a couple of different lenses to help maybe understand how we can move forward in that. And the word that's going to show up often, and Chris alluded to a lot, is the idea of concept. And you're probably all familiar with it, but I'm just going to quickly review with it just in case. We know that concepts will have a certain quality to them, and on the left-hand side, you're familiar with this exercise. It's called the concept attainment. It has different words, but you've got the word concept and many words underneath it that are examples of that concept. And all those things under that, the examples are concepts. They have something in common that make them a concept, whereas the no items don't have what it takes to be a concept. Gone with the Wind is not a concept. It doesn't have what a concept is able to have. Same with aluminum and jog and right. Now as well, so I'd like you to take a look at and I go through this a little bit slower with kids and I'm doing a concept attainment, but in a matter of time here, we're going to move quickly. So here are some examples of some thoughts of things. You've got other examples of courage, water, Christmas, and truth. Some are examples, some are non-examples. Where would you put them? Which do you think are the concepts? And the next slide, of course, is going to show you where they belong. Courage and truth would be concepts. Christmas and water don't. Because if we go to the next slide, here's what a concept is. A concept is basically a noun. It's made up of one or two words, and it's got distinct attributes. It's kind of like a file folder, if you think about it, right? We put certain things, certain attributes in a file folder, and we know what it is that we're putting in that file folder based on the content of that paper that we're putting in there. So it's got certain attributes, and they're shared with examples across, multiple examples. So all the photos there you see are examples of vehicles. But they're also, we can even create two file folders. Maybe we could we can have a file folder for trucks or cars, which are also concepts. And that would create a little bit of dilemma for the automobile in the middle, or the vehicle in the middle. Some of you may recognize that if you're my age as El Camino. So we may have to create a third concept for that, or alter what we would call that to make it fit one of the concepts. But a concept is just simply that, right? It's something that it's an idea that organizes our thoughts, and we put things in that organizing idea that have common attributes. So there we can go from concepts that are more general to specific, such as the ones I showed you with the car and truck. And the more specific the concept, probably the more subject or discipline related it is. Character, for example, would be a more specific concept related to language arts, perhaps. Whereas ecosystem may be more related to science, it's more specific. But when we talk about system or change or power or those kind of things, those are broad concepts that can be dealt with from subject to subject. So they do range in abstractness and generality. And finally, one more point about concepts. They're useful for something called the conceptual lens. And I'm going to just give you a quick example. Here's a photo of a certainly a hand in the sand and the water. And if I asked you to look at that picture through the lens of resources, what would you see? You might focus on the water and the sand as possible resources that we use to make things with, and they're useful to us. But I ask you to look through the lens of senses. You may see different things, right? You may look at it and say, I can see the water's probably cold, the sand would feel grainy, and we could start describing things and looking through that picture through our senses and focus on two totally different things depending on the lens. In other words, the concept that we're looking at the photo through. So I'm going to ask that we look through the curriculum through a couple of different lenses today. And the first is the lens of concepts themselves. So we've got the learning outcome and even the guiding question that's associated with the learning outcome, plus the cusps, the knowledge, understanding, skills, and procedures. And they are full of concepts. I'm just going to give you a moment to see if you can pick out those things that would be considered that are concepts based on our understanding so far. And as you go along, probably you're going to find your understanding of concepts is going to deepen perhaps as we go along. Nonetheless, I'll give you just a few seconds to see if you can pick out a couple concepts. And on the next slide, we're just gonna blast them out to you here. Particles a concept, a model is a concept, matter is a concept, physical properties, solids, liquids, and so on. If you look at those carefully, though, you'll see that the concepts identified in the learning outcome are similar in the cusps. And I just took one of those cusps from, I forget, it's the third column, cusp 1.3. But you'll find those similar concepts throughout all the cusps, which tells you that those are some of the important ones. But there are some other ones hiding, and I'll come to those later, but I'd like to call those verb associated concepts. The next slide will show you what I mean. We take a look at the word investigate. That's a doing thing, but in order to investigate, what you're actually doing is you're involved in an investigation. You're doing something. Describe, and I didn't finish them all, unfortunately, but describe, you're really creating a description when you're doing the skill of describing. So they're very closely related, and when the students understand the concept, they're better able to do the skill. They go hand in hand. Next slide, please. So when we go through all the cusps and the learning outcomes of this organizing idea, you'll find that there are some key concepts that come to light here, and there's a lot of them. But when you put them together, they will tell a story. They'll maybe help us understand the unit in a little bit better than maybe just the individual levels of the cusps. And I'm not going to go through that story, but you can see by throwing the connecting lines and following along, it's kind of small for me right now, you'll see the flow to the unit and how things are connected. And that's what concepts can do. You can connect them in various different ways. This is the way that I've connected them, and I think my understanding of this organizing idea is saying it's not the only way that these ideas can be organized. And concept maps are really good ways of getting kids to demonstrate their understanding. If they were just to take, for example, the bottom part out, which are the grayed area at the very bottom right hand, give the students those concepts and say, hey, connect these words in a meaningful concept map and tell me why you connected it that way. If they can do that and tell you why they made the connections in a way that makes sense, you're at that understand level. We'll talk about that in a little bit. So there's a lot of concepts in that whole concept map, but you'll find the ones that show up most often are the key ones, or ones that I'm going to call anchoring concepts, because you'll want to work at those and find examples of those and do all your learning activities related around those things, and they're listed there. And you can see that those same concepts are listed in the guiding question and the learner outcome as well. So that gives you an idea that those are the things we've got to focus on. Those are some of the important ones to worry about, as well as the other ones that were on the list, because they're going to want to know that the meanings for the time, but these are the big ones. Go ahead, Chris. And I'd like to look at the curriculum through a different lens now. This is the skills and procedures lens, the doing things. And we're going to take you through a little chart to get a sense of what that might look like. If it's not on the first chart there, first thing you'll want to do when you read those right-hand skills and procedures is to look at it, to make sure you understand what that verb is, to pull it out. And once you pull it out, you'll notice, go ahead, Chris, you'll notice that each of the cusps is made up of two parts. It's got the, do I have the right, I don't know if I have the right one here. Do I? No, I've got grade 2 there linked onto you. Sorry. You might have to pull that out, Chris. I don't know why the wrong link is in there. We've got grade 2 concepts. Can you go into the folder?
Yep.
And pull out the grade 5 one? It's in the assessment folder. I thought I had all the links tested, but clearly not.
No worries.
It's in the extra resources folder. Sorry about this, everyone.
Oh, good. Okay.
There?
It's in the assessment folder under
No,
grade.
it's not in the assessment folder. Sorry, it's under general learning or the learning, general resources
Oh, sorry, in our folder already.
in our
That-
folder already. Yeah.
Okay, sorry. Okay.
Is that, did you find it?
Just at our slide deck. There we go. Alrighty. That's not, oh, yeah, it might be.
No, that's not it.
Not in there.
Okay. Oh, that's too bad. Boy, oh boy. I don't know
Nope,
what happened
not
here.
in there.
I'm just going to double check. If you just give me a second here. Grade 5. General.
Oh, general, I'm sorry. I was an additional. No.
Well,
I wa-
that's still not there.
No, it's not there.
No.
Well, do you want to
Okay.
just explain it with the grade twos
Yeah.
and then it'll
Yeah, I'm
trans-
going to explain it
Sure.
with the grade 2s. It's too bad. It's related to what I have talking later on. Anyway, you go ahead and we'll talk about the grade 2s. Just be careful that when you do look at these statements, there's the knowledge component and the skills opponent. And in order to have students be successful at both, you need them to be competent in both. And so when you're looking at the skills, what you'll want to do is pull them out and work with them separately. These examples aren't to give an example necessarily, but we know, for example, there's comparing and contrasting in grade 5. So before you give them the statement that has in the skills procedure that has them comparing and contrasting, I believe it's densities, you want to make sure they're good at comparing and contrasting. You want to make sure that you explain what it is, they go through the procedures, and they can do it without content that they're responsible for. So the focus is on the skill, and you can give them feedback on the skill. So when you give them that task of comparing the densities, they already know what to do, and they're not competing with two new things at the same time. So we can go out of this one, Chris, and hopefully I got the right links here.
No worries.
Man, when you have so many windows open, it's kind of crazy. So hopefully we're good at the rest of the way here.
All good.
So those are the skills, and you can see those are the key ones that I have that show up in the cusps for this particular organizing unit.
And if you look at these are very interactive. These are very hands-on types of skills, right?
They are. So we're going to look at this through one more lens. We know we've got some concepts to get kids to master and to understand independently, and we've got some skills now. They've got the set of skills, and what we want to do is make sure that they understand how to do those skills at the surface level. They're comfortable with them. If there's a set of procedures with them, they can go through a set of procedures independently and follow through with that skill. Same with surface level understanding of concepts. We want them to be able to provide an example of the concepts that they can, non-examples, defining it, putting in their own words, making sure they understand those things. And once they understand that, when we put their knowledge together with the skill, that's when we can have them develop some deep understandings. And once they have a deep understanding of those things, and the deep understanding is when you have a concept related to another concept. For example, students might know what a description is, and they know what an observation is. Separately, they know what they are, they can make them, and so on. But when you ask them that question, what's the connection between an observation and a description? And they can tell you that. Now into a deeper understanding. They couldn't tell you that until they truly deeply understood those concepts, because they know how they're related now. That our descriptions depend on what we deserve, and they could give you an example of that. So if that's the learning process, going from surface to deep to then transferring and applying what they understand to a new situation, we can look at this current science curriculum through this same lens, where if we take the knowledge, the separate concepts, and the basic skills, not associated with the content part, but just the skills themselves, and they're good at that, we're working at the surface level. And we start getting them to combine those two things together. Now we're going to be attacking the understanding. And once we got the understanding and we get kids to do things like project-based learning and those other things, we're heading towards the learning outcome now, because they've got all those things. And now we're getting to the big ideas to learning outcome. The next slide is going to show you a little bit more what I mean. There's a bit of a graphic there. So if we get the kids to be really good at the surface level understanding of mass, volume, density, and compressibility, especially density for this particular thing, we can get them to, and they can then do the arrangement and movement of particles affect the physical properties of matter. They can understand that. I had this particular choice here, the skills and procedures on for a specific reason. Because when you look at it, what they're really doing, if they can account for the difference in densities of solids, liquid, and gases using the particles of matter, they are showing that understanding. Okay,
Right.
but they need to know those particular concepts first, right? Go ahead. Okay, I'm going to come back to that in 1 second again. So in order to get to a really good sense of to get kids to develop things at a surface level, and then at the deep level, and then to transfer, we need to have in our pockets a whole lot of instructional approaches, because there are a lot there, and you're probably familiar with many of these. And if you're not, they are Googleable. You can find out, and we've got some examples throughout here. You'll find that they will fit one of those three pockets, the surface, the deep, or the transfer learning area, just by how you organize them and what you do with them. The point is to be intentional when you get an learning activity that someone shares with you, or you find online, or you're creating one. Know where you're at in the learning process, and then choose an instructional activity that's going to help along the way. So you could start off with things like the concept attainment one. Sorts, jigsaws are really good at the surface level. When you get into understanding, there are some others that come in handy. Concept mapping is a really powerful one, and that hexagonal thinking. There are many thinking routines from Project Zero that are helpful as well. And then when you get into the transfer, you're starting to look at role plays, you're starting to look at project-based learning and inquiry, larger inquiries, and so on. I'm going to take you through, or let's look at the next slide then, because the question becomes, how do you assess all this? When you're at the knowledge, I'm just going to go back one more slide, Chris, or just that original slide.
Sorry?
Yeah. There are some questions underneath of those that can help you to determine what kind of assessment you want to set up. So at the knowledge and at the basic surface level for those knowledge and skills, you want them to give you examples of concepts, for example. You want them to define it, put them in their word meaning, be able to distinguish between two. If it's a skill, that they're fairly independent with it, with content that's not course related, so you can feedback on it. If you're looking for understanding, there are some questions you could have the kids do, because understanding is when they start putting those ideas together and using the skills with the concepts. Now they're demonstrating understanding. And then same with the transfer part. Can they now apply it? Can you have them take that understanding in a brand new context and something they're required to do more independently? And that'll be moving towards the transfer part. So go ahead, next slide then, Chris. Let me give an example on this next slide. Oh, it was the one that, sorry, it was the link that you went to, Chris, sorry. Right. So I've taken, again, those same three cusps that we looked at earlier. The physical properties of mass, volume, density, and compressibility, and the arrangement and movement of particles affect the physical properties of matter is the understanding. I took two statements out of the skills and processes, or skills and procedures part. Because then if you take a look down, there's what's in the curriculum. Now at an instructional approach, what am I going to do? So for the basic knowledge there, you'll see that we want to give kids opportunities to learn these things independently. What is mass? There's lots of videos out there. You can do concept attainment thing. I know we're going to find out there's lots of gizmos that you can do. You can learn these things at that level. And if you go to the right-hand side, if comparing his activity, I have a link there to a skills teaching strategy that are useful for many different skills throughout this curriculum. Are some steps you can go through. Here's how to teach comparing and contrasting. You can apply that to any of those skills. So there are steps of what to do to plan for that. Then the instructional activity that I'm going to use was on the right-hand side. If you take a look at that word in that middle column, it says compare the density of solid objects of similar volume. I'm going to use that to develop an understanding, but by just having them compare those things is not enough. So then they go through the activity, they're going to compare the densities of solid objects of similar volume. But then to get to the understanding piece, I'm going to go, if you go scroll down a little bit, after that activity, then I'm going to ask them that question. All right, we've just made a list of all the different volumes of different things. We've compared them. They're different. So count for that difference in those things using particle model of matter. We can't ask those questions unless they really know. We can't have them do that unless they really know what those individual concepts are. And they can't really complete that activity until they know what a comparison, so they could do that activity. Now they're putting their understanding together. If you take a look at they're really relating. What's the relationship between densities of solids, liquid, and gases, and particle matter and particles? What's going on? What's the connection between all those? You could also take all those words out of particle theory, put them together with these other ones, and have kids to put it together in a concept map. And now you're showing their understanding. So to assess skills, give them a skill, give them something that's not related, that they're not related to. It's on the right-hand side. Give them content that's not related to the course necessarily, or that they're responsible for. So you can give them feedback on the skill. If you're assessing the concept, give individual things to assess their understanding of that individual concept. And there's an example there you could take a look at if you want later. And then you can work at the understanding. Once you have the understanding, then you can work to those larger case studies and project-based learning things. And I think I'm pretty much done, except for one thing. Chris is just going to take you through and one more step, and that is that we've got to take a look at a planning document that you may want to use. I won't go through it much, but I'll just share some of the highlights. This is something you may want to use. What it has is a place you can put down the area of focus that you're working on right now. There's drop-down menus for the different knowledge, understandings, and skills that you say, here's what I want to work on, and pull them out without having to copy and paste. After you're done, when you're done your planning, you may see that I'm not hitting any of the competencies, because when you're looking at this, you want to make sure that kids are doing something that addresses some of those key competencies there. The concepts for the unit are all listed underneath there, the skills as well. You can pull them out for your planning. And then there's room at the bottom to plan for surface, deep, and transfer activities as well. So it's there to use if you want. And boy, sorry, I was going 100 miles an hour. We've got lots to do today. If there's more questions, please feel free to fire them my way. We'll be looking at putting on some sessions likely that will deal with those three levels a little bit more completely. But right now, what Chris and Amanda are going to do are take you through a lot of examples. And as you're looking through all these examples, I'd like you to look through all of them through a third lens, and that's that lens of where is this activity and resource useful for surface, where is it useful for deep, and where is it useful for those transfer activities. Thank you.
Great. Are there any questions for Ted? Those skills are absolutely critical. And I think Ted's point about teaching them outside of the science is the biggest piece that we really want people to understand and really resonate with you, so that you're really, it's the same thing as the concepts. When Ted showed you concepts, he used trucks and cars. That's something you can all relate to. Had nothing to do with science. So the same idea with our kids. If we're going to teach them to identify something, have them empty their lunch kit on the table and let's identify different food groups. Like, just teach them the meaning of the concept, or sorry, of the skill that we want them to be able to demonstrate with the knowledge of the science at a point that we are able to assess them then. So we want to make sure that those are two really married together tightly. So we are looking at the particle model of matter for sure in this. And I almost question, Ted and I were talking about this earlier, it drove me a little bit crazy in the grade 3 unit not to have this conversation in there, because it was a logical place for us to be having the conversation with the students. But nonetheless, I mean, we see this is movement over time, and that we're not sort of just moving on an isolated idea within a grade. So in the grade 5, we're really taking that particle model matter. We're talking about the different ways that matter are arranged and how does that change under different circumstances. And then we talk about the densities, masses, and volumes. So as I was unpacking this, and I mentioned at the early onset, this is not an isolated topic. Therefore, I need to make sure I have the tools that the children have arrived at the door with, and they're not going to have done the new science curriculum this year arriving at your doorstep. So we need to be cognizant that before we launch into the grade 5 piece, there are some things from grade 3 that you may wish to go and pick up, specifically those states of matter. Like if they haven't been exposed to that or don't remember it, or it's well worth your while to spend at least one period at reviewing that, or even more if need be, because I think this is where you're going to have to hang a great deal of your information. This is a video that we have, it's in the grade 3. I'm just showing you a couple of slides that I pulled out that I think are absolutely critical for grade 5. You can go to the grade 3 folder and grab whatever you want from there as well. But for the states of matter, this is a great video because it goes through the 3 states, it reviews it with them, but it also asks some questions in between. And we've even said to teachers, why don't you pause it and get some answers from them? And as a grade 5 teacher, that would be a great formative for me to find out what the kids know and don't know, because that's going to be my move forward as I get a sense of where they're coming from and what they're able to do. And then at grade 3, we asked them to write down examples as they were hearing them in the video, because we use the video as the intro to the 3 states of matter. We didn't stand up and do a direct teaching. We said, let's watch this first. Let's write down things that we've learned, and then we have an activity for them and the characteristics that go along with it. I also created a card sort for them. We did a foldable for the students in grade 3. I'm not suggesting you do the foldable in grade 5, but the purpose of the foldable was their entire unit is in the foldable. But that said, when I look at the cards that we created, they're hexagons. After they've watched the video, we ask them to take those characteristics of each of the states of matter and put them into the correct pouches. And that was a great discussion, or a way that they would be able to have some discussion then about, there may be some that they feel fill in more than one particular area. So again, that card sort is available to you. You don't have to have the foldable. You could just have 3 words, solids, liquids, and gases on the table, and they could just sort them accordingly based on that. If you're finding that the students are not strong in that area, we have demonstrations and activities. So each one of these are hyperlinked for you, and they're matched to the color over here. So either demos or activities based on change of state or different qualities. If I'm trying to go from a liquid to a gas, or if I want to go from a solid to a liquid, or so on. So again, if those are things that might be helpful to you, that might be a starting point. But when I look at the grade 5 and I start to pack these together, I look at the fact that I'm talking now about particles, right? And we've kind of missed that whole conversation. In grade 3 would have been a good place to have it, and we could touch on it, but it's not the focus. So when we talk about the particle matter and we're looking at how they're arranged, we're also looking at how they move and what makes them move. And when we talk about heat, because we did talk about heat in grade 3, but we don't talk about how it affected the molecules within there. So now we're going to talk about how those different states can be changed and what happens to the molecules within. What happens to those attractive forces? What are the forces like within each one of them? So as I was unpacking this, and I'm going to talk about these in just a second, I started to grab exactly what Ted was doing in the same way. I was starting to grab some of the skills and what they were asking us to do to unpack this matter. And again, it becomes very interactive, much like the grade 4s. When I was doing the grade 4 one yesterday, that was one of the things I said to them. This is not in my world. This is just a suggestion as it is here. In my world, the grade 4 was not a stand up and deliver one at all. It was more of a case study, divide and conquer, and let's bring back information, and then we unpack it with the students. In grade 5, when I'm looking at this, if I was going to go in the classroom right now, I definitely want this to be very interactive and very hands-on, understanding, and I appreciate William saying that he was doing it with chemistry, because that would be the logical place to tie in the old stuff. But really, when I look at this, I was in my mind looking at, I'm always looking for resources for you guys, and that's really what I was trying to find, was what is a way to engage you, the students, to give you some tools that you may not have in the classroom right now, especially if you're new to this particular topic. What do we have? So in that vein, there's a couple of things. These are very interactive. And I'm going to unpack those in just a second. But when I look at these as well, these physical properties, although they've already talked about mass and volume in previous grades, your grade hasn't, because they weren't in the new grades yet. They may know something about it. We do need to be intentional that they know what mass, volume, density, and compressibility are. Like, that is a definite piece that we have to maybe step in and do some teaching, or at least expose them to it again before we start doing some of the arrangement of molecules and those, so that there's a clear understanding of that term, because that's going to be really critical and really imperative. So in my search for resources, I have been purchasing resources, been contacting publishers to see what they have. I received a new resource this morning, and it was really timely. So I just put a snapshot in here right now, and it has to do with just unpacking again the 3 states of matter and how do the molecules get represented in each one of those. So this resource is quite nice, and I like it because it's also very focused on compare and contrast, or it always has a skill in it that we're looking at. It's not just straight factual information. To me, that's the more important kind of quality resource that I'm looking for. This is what it's called, Energy and States of Matter. You've got the information. You'll have all this later, so you don't have to worry about it now. But again, this is just one of a number of resources that I have from them. But when it came to all of this, and I'm thinking, okay, I've got a ton of books, but you know what? Books is not what you need here. So what do we need? We need something that's hands-on and interactive. And I really was cognizant, I spent 43 years teaching in rural Alberta. So I know that not every classroom is outfitted with everything under the sun. And how do I make this interactive for every child and provide tools to every teacher? And Gizmos came to mind. And that is why we have a guest speaker with us today, and that's Amanda Wilson, who is on your screen. Amanda is with us from Explore Learning, and she is, I'm going to show you the whole thing that I have found for you to unpack this unit. Less than the lesson plans that I normally would give you, or those lesson kinds of things, but this is, I've gone through them now to see what we have that would work for Alberta, new curriculum. And I'm going to play a very short video clip so that you can see what this is all about. I'm going to show you just a few things, and then I'm going to turn it over to Amanda for just a bit to unpack just one of those for us, show you the teacher or the student resource that goes with it, because you could teach your entire matters unit for grade 5, with the exception of few terminology, directly through the Gizmos process. So let me just go out of this one for a second. Just going to log in here. So when I went through and had a look, I will show you after this video a very short page that I will share with you. I did tool it up to Alberta curriculum, and I did number it according to our outcomes, and I did cull through the things that would not work for Alberta. But let me just give you a short clip on this, because I think it would fit very well.
Welcome to Explore Learning STEM case on properties of matter. This case study is appropriate for elementary school level and takes approximately 35 minutes to complete. In this case study, students play the role of a forensic scientist working for the Secret Service. They begin by reviewing evidence discovered by the FBI while investigating a case of counterfeit coins. Before students start their investigation, they first review the background information needed to solve the case by entering the embedded handbook. This includes an introduction to matter, that particles in matter are too small to be seen, properties of matter such as color, temperature, and hardness, physical changes including heating and cooling, the 3 states of matter, gas, liquid, and solid, and mixing matter including dissolving matter to make solutions. More topics are covered in the separate expanded handbook. All of the cases include questions for students, and teachers can follow their progress in real time using the heat map tool in their Explore Learning account. Every case also includes a scientific glossary to help with new terminology that is grade appropriate. After completing the handbook, students return to the case to analyze the evidence and form a hypothesis. They then test their hypothesis with a series of experiments to replicate the methods used by the suspects to make the counterfeit coins. Finally, students complete a case summary to communicate their findings and help develop their scientific writing skills. By engaging with a real-world case, students learn science by acting like scientists. Learn more at explorelearning.com.
Okay, so let me just take you back quickly here. So as we don't have anything posted for resources yet on our science website, one of the reasons that we do look for resources is for just that reason, is that people are still looking for new things that fit into different grades than they're used to seeing. So this is just a sample of some of the sheets that would go along with the density or one of the other programs that we're going to be looking at as well. But what I wanted to just show you was this is the opening page, and Amanda's going to take us there. When you come to this opening page, you'll see all of the different programs of studies. But when you are looking for science, and that's just maybe a note, Amanda, it says about Alberta 2022 draft curriculum. So this is actually the Alberta Science draft curriculum. That's what this is. It's found in the bottom right-hand corner. And so I've clicked on grade 5 for us to go forward. And when I do that, and I look for the pieces that we are looking for, and Amanda shared this, I've just screenshotted the piece that deals with matter, the part that we are dealing with right now in grade 5. And these would be the programs. Now, the numbering that occurs in there is not our numbering. This is something that is specific to the program for Gizmos, and that's fine. It's not a big deal. But what I did do is I went through every one of these to see what's a match and what's not a match for Alberta curriculum. And I just retooled it for you so that you actually have it in brackets with our numbering. Here's the grade 5 matter 1.1, 1.2, 1.3, 1.4. And we aren't going to do cellular respiration. That doesn't fit in to this particular unit that we're doing. So the Alberta version of it, or just the abridged version, let me throw that in the chat box and you can have that right now. And then I'm going to turn it over to Amanda. You do have sharing rights, Amanda, as well. And welcome, Amanda. She popped in today as I phoned her this morning and said, hey, I just had a brainwave. We want to do Gizmos because our whole unit pretty much could be done with Gizmos. And can you just join us? And she said, yes. So thank you so much, Amanda. We appreciate that. Now, if you have not got a login, she's also here for that. So we're here to help. If you're saying, this is cool, I want this, I anticipated you might want it like right now, not 2 weeks from now. So you can do that with her today too. So I'm going to turn it over to you, Amanda.
All right. Welcome and thank you for having me. I am going to put.
You want me to stop sharing or?
I will in just a second in chat. Unfortunately, I'm currently only using one monitor, so things are a little bit wonky. In chat, if you do not already have an account, if you can send me your division, your school name, and an email address to alberta@explorelearning.com, I will send you an invitation. And I think Chris has a slide of what it's going to look like.
Oh,
And there's going to be a blue box, and you're going to click on that blue box, and it's going to walk you through how to set up an account.
I'll put it back up. This is what it looks like when you get it.
And I'm thinking a few of you may already have accounts. I'm not sure. Anybody already have an account? Anybody? Nope. Nope. Nope.
Randy does, yeah.
Hi.
No, William, if you get the invitation, I will give you, you'll have access for the school year. So that's why I need all that information so I can send you an official invitation. So you don't have just the 30-year.
Okay.
Now, Randy, your invitation expired. Again, send me, or you can even put it in the chat if you want, but it's division, school name and email address. I don't even need to know your name, but if you'd like to, you can send me your name. All right, so Chris, you put me on the spot. I didn't know I was going to get to demo what Gizmos looks like, but not a problem.
Well, it would also be nice for them to see the book that maybe goes with the properties of matter, just so that they have a sense of what they might be unpacking. If you can even just show us a glimpse of that. I mean, I can do that.
So what Chris was showing you is what's called a STEM case. And those are interactive experiences that the student can participate in. And you actually get the heat map and see what they are, how the students are moving along. We have just started making them for elementary students. It may take an elementary student longer than 35 minutes. I'm going to be honest, the middle school version of ecosystems is only supposed to take 30 or 40 minutes, and it took me like 48 minutes to get through. So those time frames are a little, I think, shorter on the short end. So I will start sharing, screen share.
Yep, you should be able to. I made you co-host.
Okay. All right. Everybody see what I'm,
Yep.
see my screen? Okay, without all the other random things. Okay, so when you first log in and you get your account, you're only going to see one product. It's going to be Gizmos. I have access to all 4 of our products. We have 2 math products, and then we have a pre-K to 5 Science for Us product. But Gizmos is what you have access to. The Alberta Ed purchased subscriptions for all K to 6 science or math teachers, but once you get in, you already have access to all the science. There's no way. So you have it for science, you have it for math. So when you first log in, this is your dashboard. I think I'm just going to show you a just what's available. So if I just type in matter under Explore, you're going to see there's a lot of options. So we do have those STEM cases, which are going to take a little bit longer. There is a handbook that goes above and beyond the STEM case that Chris was sharing with you. You will have to invite your students to a class for them to do the STEM case, because they have to have an account to do the STEM case. So I think one of the gizmos you were showing, Chris, was it Properties of Matter?
Yep.
Or States of Matter, Stages of Matter?
Properties of Matter, yeah.
Water cycle. All right, we're not going to go there because it's not coming up. What Chris did was browse by grade and topic. Grade 3 through 5, physical science, and properties of matter. So here is what you are going to see. What also the other thing caveat I want to put in there, Chris, when you went through and showed the screenshot that included cellular respiration, for some reason, they're putting all the STEM cases in that don't belong. So we're working on trying to figure out where that bug happens.
Yeah,
so
it has
here,
a place, it just doesn't have a place there.
yeah, and cellular respiration shouldn't be there. And actually the one that it's linked to is the high school one. So we do have a ticket in to have that fixed. So you'll see that there's multiple gizmos, and then there is one STEM case that would be appropriate for your students. Properties of Matter, which is interesting. As I was watching that video, I was now watching it through the lens of a Canadian, and I'm like, all of those references are all very US centric.
Mm-hmm.
So something to think about on my end. So viewing all results, let's go to properties of water. What you have access to, you can add it to your class once you create your account. But the resources that are available to you is the student exploration sheet, the answer sheet key, a teacher guide, and the vocabulary sheet. Usually what I do when I first get into a gizmo is I look at the student exploration sheet. It's going to require you to download it. And it's going to have your email address up here. So if it gets posted somewhere in the world of, in the internet world, we will call you and let you know or send you an email. Can you please take that down? So each student exploration guide will have prior knowledge. It will have a gizmo warm-up. The intent of the gizmo warm-up is to support the students understanding how to use the gizmo, because we find if the students don't know how to use the gizmo, then they're not going to be successful. So I like to get into a gizmo, and the first thing I'm going to ask the students is, what do you notice? What do you wonder? So I want them to see, what do they see in the gizmo that they think they can do something with, and what are some questions that have been generated in their mind. Then most gizmos have multiple activities. So you'll see activity A, activity B, and then there's an extension for volume and density. We want you to be the practitioner and determine what it is you think your students need to reach that learning outcome using the cusp, the knowledge and the skills and the understanding. So what we encourage teachers to do is go in and be very intentional about what we're going to ask the students to do, because it may be, and most often, it's not all going to be attainable for your students. Gizmos are made for grades 3 through 12. So looking at properties of matter or properties of water, I can guarantee part of this will be applicable at elementary, part of it at middle, and potentially part of it at high school. So here's the student guide, or the key, because I need to figure out what it is the students are going to be doing, and I need the key because I am not a chemist. I am a botanist by trade. So I'm going to look at the key first. I'm going to, whoopsie, make a decision on, okay, that is something I definitely want my students to be able to do. And boop, boop, boop. Sorry, I am on like I said, I usually have dual monitors and this works a little bit better. I'm going to go back to phases of water, and there is a student exploration sheet. We also have it available in French, and we also have it available in Google. You do most things in Google, is that correct? Or a little bit of everything?
Depends on the board.
Okay, depends on the board. So we have lesson material available as a PDF, Word, and a Google app. Google is great because it's an editable document, so you can assign it to the students and they can do it online and then share it with you. The phases of water SE, that's the student exploration guide. Can you see it? You probably can't, can you?
Nope.
Nope, okay. I need to go back in and new share. Okay, let's just do the screen. Boop. All right. Phases of water. I guess I could use my mouse. That will probably work a little bit better. Bringing it over.
Yeah, there are pieces, William, you're correct. There are parts in here that are grade 6. And I noticed that too, that there'll be some statements in there that are grade 6, but again, this is where some discretion comes into them, and you can use them again.
Well, I know,
And
it's
that's,
trying to teach the phases of matter and not being able to talk about like the phase changes in water, or not being able to, but it's saying that is a grade 6 outcome has been really frustrating.
It is. That's how I felt in grade 3. I just wanted to rip my hair out and say, what the heck? Like, put this together so that we can just talk about it. But yeah, I get it.
so looking at the student exploration guide, I would take everything out that I don't want the students to do written. So this would all be pieces I would take out, because in prior knowledge, I'm going to ask the students to either engage with me or engage in a thought partner. The Gizmo warm-up, I'm going to do with the students' whole group, and there's nothing I necessarily want them to write. So I'm going to remove all of this. Currently, if you notice, there's like 5 or 6 pages. If you gave this to a 5th grader, they would probably cry. And let's be honest, you would probably cry if you had to grade all of that. So I'm going to cut all of that out. I'm going to leave the vocabulary because it's helpful, but some of those vocabulary words may not be applicable to your current grade level, as William had suggested. And here's activity A. Now I'm going to look at activity A and I'm going to determine, do I want to do all of activity A? This goes back also to what I'm totally blanking. Ted, sorry, Ted. Ted was saying about skills. You'll notice that observation, hypothesis, predicting, those are all skills we need our students to be able to do, analyze, and also extend their thinking. So it may be activity A is appropriate for my grade level. So this is the activity I want the students to do. And I'm going to erase all the rest of this because it's not applicable to my grade level. I'm going to also look at this activity and decide, okay, how does temperature affect the phases of water? Before they extend their thinking, I'm going to want them to write what they think. I want them to answer that question. Control C. And for 5, I'm going to change 5 to asking that question. I'm obviously not doing a great job cutting and pasting. Control X. Paste. Keep text only. And I'm going to give them some space to answer that question. And then to extend their thinking, this might be something I have them do in pairs. Describe an example of phase changes you've seen in real life. I might ask them that question and then have them share out with their thought partner, and then we'll come back to class. So being very, very intentional about what you're asking the students to do. I also encourage you to take off the activity A, because what's the first thing the kids are going to ask you?
Is there a B?
Yep, there's a B. So I always take off that piece and really think about what you want the students to do. And it may be during this process, you're going to have them do part of this whole group. So it may be you get them into the gizmo, they start looking at what they can do with the gizmo, and maybe you're going to actually model the observation piece for them, and they're going to work with you whole group. And then individually, they're going to create a hypothesis, or with their thought partner, they're going to create a hypothesis. Then they're going to make predictions, collect data, analyze that data, and then complete that original question. We called them essential questions. You may have a different terminology. What the essential question of this activity is, and then again, the extend your thinking, which might be homework.
And I think the extend your thinking, just to be intentional again about what Ted talked about, knowing what the skills are that you're really honing in on in that unit, right? This is an opportunity for us to use those in an appropriate way, assuming they already have the understanding for it.
And I'm going to log back in. It didn't log me out. I just can't see that one anymore. It's there. So right back in. Lesson info is more for you to determine if this is where you want them to go. I also encourage you, don't ever assign a gizmo without doing it yourself. Launch it. Get comfortable with the gizmo. And these assessment questions I would never use, because gizmos are made for grades 3 through 12, and they may not all be applicable to you. Maybe there's 1 or 2, but I think there's a better way to assess them than asking these questions. If you choose to, the answers will show up as soon as the student completes the assessment. So if Amanda's sitting behind Miranda and she's looking over her shoulder, Amanda's going to get all the answers right, and that's not necessarily going to be a true evaluation of what Amanda knows. You can also make it super big so the students don't have anything else going around. It's going to give you the ability to drag your magnifying glass over. There's temperature controls. We can change the temperature. And ice, heat, and how do we get this one to go? I haven't used this one in a while. There's usually a play button. Water vapor.
Yep, that one.
I bet there's something oh, here we go. So as I increase the heat, there's ways to change. This should actually, there we go. It's heat, the water is boiling. We can come in here and actually look at the particles moving over on the other side. We can look at the particles down here as it's boiling. So it's extremely interactive, asking the students to visualize and then understand and write about that concept. So it's really also bringing in this idea of, can the students write about and share their understanding and their knowledge?
And in this unit, remember that one of them is to definitely visualize and observe models in action. So if you don't have a science lab in your classroom, this does give you that opportunity. That doesn't mean that you couldn't use a YouTube or something like that, but at least this one, you have some ways that the kids can go in and adjust and see what happens to the molecules, right? Where you don't have that, we have that limitation when we're doing it with the YouTube.
And it kicked me out. Sorry
Oh.
about that. I think because I got too many windows open. Boop. So I think for your purposes right now, one of the greatest ways to go in is look at browse by grade and topic, science, physical science, and for this unit of study, properties of matter, and look at everything that you have here. What are your options? Do you need them to be measuring with volume? I know density was one of the concepts, one of the larger concepts that Ted was talking about. Chemical changes, if they asking the students, is this something they want? You can also, without opening up the gizmo, you can just look at the lesson info. The teacher guide is extremely helpful. Usually, it's going to give you learning objectives, suggestion lesson sequence. Also, there's usually activities you can do. But what's great too is usually on number 4 are these discussion questions that you can use to engage the students, do informal discussions with the students afterwards, or even maybe use it as assessment questions at the end. I'm going to scroll down here with the background information. I said earlier, I am a botanist by education, and I found myself teaching earth space science. I never had a geology class in my life, but now here I am teaching plate tectonics. So this background information was essential for me to ensure that I was able to have the students understand the information without misconceptions. It sounds like many of you are having material in your units of study changed. So maybe you're teaching a content or a subject or a concept that you haven't taught before. So this background information can be super, super helpful in getting you prepared. There's also sometimes historical connections so that you can couch what the students are learning and understanding the greater worldly view of that content. Any questions about gizmos?
I should mention as well that gizmos, Amanda has a team that will train your entire school if it would help for your school on a PD day to get info on how to get on these. And the reason I'm really bringing it up now is because we don't have any links right now in New Learn Alberta for science. This is your back door into them. So this is a great way for you to have access to math and science gizmos that you can use right now until we decide what those resources are going to look like or what they might be. But it does give you some instant access to that, and I think that's really important for you to have. So just keep that in mind as well, that if you feel that there's other people on your staff that would be helped by having a gizmo access, it's not hard. You found out how that worked, and I think that's really all we really need to work on from there. So anyway,
I'm sorry, to answer some of your other questions, William said, do we have Google integration? No, we do not integrate with any learning. We do not integrate with any learning management system. They're Google, the Google apps like Docs and Sheets and Slides can all be used, but you can't just log into Google if that's your LMS. And the reason why is there are about 7 main LMSs, and if we were to integrate with one, we'd have to integrate with all of them, and that is we'd rather our development team spend time building new resources than trying to integrate. What you can do if you're using Google is put a link to the gizmo. So once they've logged in, they can click on the link and that will take them to gizmos. That's what most people do. Let's see here. looking if there was any other questions. Looks like there's not. If you don't have access, see, I'm going to take that information out of the chat and I will send you an invitation. So I've got Danielle and Leanne and Randy. I'll grab yours. William, do you already have an account or did you put your information in there?
I emailed you.
You emailed me. Okay, perfect. Any other questions that I can answer about gizmos? I see a new message. All right, thank you, Colette. You emailed me too. I'm not sure if I'm missing anybody else. I am going to, I got Randy, invitation expired. All right, I think I got them all. So if you have any other questions, you are welcome to contact me at that email. Chris and Ted also know how to get a hold of me. And like Chris said, we can do presentations either virtually or in person. I have a team of 3 that are actually housed in Alberta. I'm in Seattle, but I do travel to Alberta about once a month. Yay, Randy, excellent, fabulous.
Okay, thanks,
All
Annette.
right. You're welcome. Is there anything else you need me for, or are we good to go?
That's great. Just for anybody who's watching, we know that there's lots of people that emailed and said they couldn't come tonight. So for those that are watching the recording now, you see the link at the bottom that you can just email. If you want access to the gizmos for the science, then just email and Amanda will get you set up and we'll be good to go. So thanks so much for joining us. I appreciate that.
Thank you, everybody. Have a wonderful evening.
Yeah. So one of the things I just want to finish up with is very quickly on the fact that there are pieces in the gizmos that are not well covered, and that would be those terminologies that we were talking about. So there would be a need, definitely with the current grade 5s, to have a conversation about the terminology surrounding mass, volume, density, and compressibility. The mass and volume they have had before, but nonetheless, there would be a need for us, I think, to spend a little bit of time on these. So what I did is just give you some quick resources. These are just YouTubes that explain, but they also demo the modeling that we're looking for as well. And they're all about 2.5 minutes long. So they're not extensive, and it still allows me to move forward with some of the activities that you would find. The other piece that I have for you here, and I'll just click it on quickly. You have this whole slide deck in our resource file. This comes actually from Australia because I do a lot of work in the sense of looking for resources from there, because between Ontario and Australia we have a lot of connections in our curriculums, and you'll find a lot of materials in here that will allow you to have, again, additional information, assessment pieces, even sometimes just some downloads for case studies that the kids can read. So it's a matter of just going through this. Not all of them are up to date, I can say that, because it's not the most current version of it, but nonetheless, Fuse is their sort of equivalent of our Ministry of Education resource bank that they would use. I'm going to include this as well in the bank, that if you're looking for a rubric that you could do for assessment, especially if they're doing some hands-on learning and they're giving you a product, then this would give you a chance to do some level of assessment. Not that this is the only rubric. This one comes from the Ontario Ministry, and they have a good tie to the curriculum that we have. And then looking at some other book resources that I've found over time, this would be very appropriate if your children don't know anything about states of matter. This little book here called Nature of Matter. There's another one that's called Solids and Liquids. Another one that's called Analyze It. So this is introducing them to our scientific method. How do I take the information? What do I do with it? How do I draw conclusions from it? This is a graphic book. Kids are into graphic novels these days, big time. And so this is one that's just called States of Matter, but it's done with a graphic illustration, which would be a pretty big hit for most of the kids. So they're listed here for you. The graphic novel comes from Capstone Publishing, and they have a whole series of them, of books that are in there. They're all graphic. The Science Flex, the one that I showed you at the beginning, which is the brand new resource, is listed here as well. And the small books that I showed you come from Pearson. And they have a library of resources that you are welcome. They sent me a link and they said if any of the teachers want to go into the library for a 30-day free trial, you can go in and just look at all of their resources and see what's available in science that may match what you might be looking for if you were looking for some gaps or holes to fill. So those are here. And if you do find something, let me know and I can tell you who sent this to me and they can help you out. But that just gives you a starting point for some resources.